Okay, so the activity that you worked on yesterday in class and perhaps finished up this morning was looking at what if we start with a function, and the function we looked at was the square root of x, and put numbers in front of it, at the end of it, inside of it, adding or subtracting, and then the u's also looked at inside if it's multiplying. So we're going to be able to talk about which each of these letters did. So A was the number in front. That was actually part C, or the third part of the activity. And hopefully you noticed that it pulled or stretched out. So this is called a vertical stretch or compression. And or a vertical flip. So how you know if it's a stretch or compression is that if A is a number bigger than 1, so 2, 3, 4, then it's going to stretch the graph out and make it taller. It's a compression if A is between 0 and 1, or I mean like a fraction or a decimal. So 1/2, 0.5, 0.75, 0.3. So if it's less than 1, it's actually going to compress or make the graph shorter. How you know if it's a flip is if A is negative. So if it's negative, it's going to reflect it about the x-axis or flip it upside down. M's, you don't have to worry about writing down K, but U's, we're going to look at it. This was the part D, or the number that was multiplying inside the square root for the activity. So K is the same type of thing, but now it's going to be a horizontal stretch or compression and or a flip. Here's where you have to be careful though. Hopefully when you did the activity, you realized that when K was 2, it actually squished the graph in horizontally or compressed it this way. When A was 0.5, it pulled it out and made it a little longer. So it's actually the opposite of here. It's a stretch if it is a fraction or a decimal between 0 and 1. It's a compression if it's bigger than 1, but still it's a horizontal flip or a flip around the y-axis if K, these should all be K's, sorry about that, is negative. So if K is a decimal between 0 and 1, it's a stretch. If K is a number greater than 1, it's a compression. And if K is negative, it flips. Now, I'm going to use the short form BW because bracket world, it's always opposite. It's like when we grabbed the vertex for our parabolas. If it was x plus 2 in the bracket, the vertex was actually at -2. So that's why this opposite exists. And hopefully that makes sense when we come down to the P, which was part B of the investigation when we had a number adding or subtracting under the square root, that it moved it left or right. So it was a horizontal translation. Translation is just a fancy math word for movement, but it was also inside the bracket. So in bracket world, you had to be careful. If it's x minus a p, you actually moved right whatever p is. If it's x plus p in the bracket, you're going to move left whatever p is. So you have to be careful and remember to move the opposite. Q was the number added on at the end. That was investigation A because it tends to be the easiest and the most straightforward to see. Hopefully you realize that that just took the original root and moved it up or down. So Q is a vertical translation, fancy way of saying it moves ups or down, and what you see is what you get. If it's plus Q at the end, it literally just moves up whatever Q is. If it's subtract Q, then you move down. It's not in the bracket, so it makes sense, and what you see is what you get. So I'm going to do some examples. I'll let the M's know when they don't have to watch anymore, but I'm going to start with this here. Maybe zoom it in a little more. So I have this picture. F of x can be given to us as an equation, but it can also just be given to us as a picture. So this picture right here is called f of x, and that has to be given to us because now we're going to graph all of these things to f of x. So the first one is f of x plus 1. That's a number at the end. That's a q value, so it's vertical, and what you see is what you get. That literally means move the graph up 1. So I'm going to go to the graph, and I'm just going to move every point up 1. And so I can label this one f at x plus 1. A plus 1 at the end means take every point and move it up 1. So then the next one, b, f at x minus 6, again, it's at the end, so it's up or down, and what you see is what you get. That just means move down 6. So I'm going to go back to the original because that's f at x. F at x is the black line, and I'm going to go down 6. And if I join it up, my resulting graph is f at x subtract 6. So we don't have to do a table of values anymore. We can interpret the numbers. Now I have something inside the bracket. So that's inside the function. That's our p-value. So p's are left and right, but you have to be careful. It's in the bracket world or bizarro world if you had watched Seinfeld. But what it really just means is at the opposite. So because this is x minus 2, I'm going to shift all the points right 2. So I'm going to go back to my black graph. I'm going to start over here to make it a bit easier. And I'm just going to take each point and shift it right 2. I'm not changing the height. I'm just shifting each point right 2. And the resulting graph looks like that. So that's f at x minus 2. Because inside the bracket is left or right, but it's opposite. So now f at x plus 4 means I'm going to move every point left 4. So I'm going to go back to the original and just count each point left 4. And you can see where different colors helps you get more than one graph on an axis, because you can still make out what's happening. So this is f at x plus 4. The last two are our a's. A's are the numbers in front of the f. So this is a equal to negative 1, so that's going to be a vertical flip. So I'm going to go back to the black graph and I'm going to just literally flip it upside down. So wherever the y coordinate was, I'm going to go to its opposite. So this was at positive 2, so it's going to go to negative 2. That one as well. That one as well. This one is at positive 1, so it's going to go to negative 1. This one still was at positive 1. This one was at positive 2, so it's going to go to negative 2. This point had a height of positive 4, so it's going to go to negative 4. Because I'm flipping it upside down, I'm not changing the horizontal location. I'm just flipping it or working with the heights. So this one is negative f at x, because a negative in front flips it upside down. So now the last one we're going to do is 2 f at x. Well, again, this is an A, so this is going to be a vertical stretch. F at x is another thing for y. Y means our height. So this literally just means double all your heights. So this had a height of 2. It's now going to be 4. I'm always going back to the original black graph. This had a height of 2, so it'll be at 4. That height is at 4. This was at 1, so it's going to go to 2 when I double it. This was at 1, so it's going to go to 2. This was at 2, so it's going to go to 4. This was at 4, so it's actually going to go to 8. So it's the same basic shape, but it's been elongated or stretched. It's as if you grabbed it, and sorry, you can't see it that way, and you stretched it out. So that one is 2 f at x's. You double the height. F at x is another way of saying the height. So that's how we can do it separately, one at a time. If it asks you for the description, it's just looking for the words like up 1, down 6, right 2. You just have to put into words what it's doing. Now we're going to look at what if we have more than one number happening at once. So we're going to graph negative 2 f at x minus 3 plus 2. So this is my final graph is going to have all the numbers. It's not like this one where it's one number at a time. Each of these numbers are together. You always have to do A and K first. M's, you never have to worry about K. So in this case, we have to deal with the negative 2 first. That's A equal to negative 2, which is going to be a vertical flip and stretch. Flip because of the negative, stretch because of the 2. You have a choice. You could flip it upside down and stretch it, or I can do it at once because negative 2 times f literally just means take all your y's and multiply them by negative 2. If you multiply them by negative 2, that's going to accomplish the flipping and the stretching together. So this height, this y, is at positive 2. If I flip it and double it, it's going to give me negative 4. This point is at negative 2. Negative 2 times negative 2 is positive 4. I'm flipping it and doubling it. This point is at 1, so it's going to be negative 2. This point is also at 1 height, so 1 times negative 2 is negative 2. This point is at 0. 0 times negative 2 is still 0. And this point is at negative 1, so that's going to multiply by negative 2 to give me positive 2. So now if you see the shape I get, it should be the same shape, but it's been flipped upside down, and it's as if someone grabbed it and pulled it out and stretched it. So the negative flipped it, and then the 2 stretched it. So you always have to do A first. Now, if you want to, and you feel confident, you can actually do P and Q together, because this means now I'm going to move right 3, because subtract 3 is inside the bracket, so it's the opposite, but outside the bracket it stays the same, and up 2. Because I want all these numbers applied together for my final answer, I'm going to work now from my blue graph, and I'm going to take each point and I'm going to go right 3, up 2. I'm going to go to the next point, right 3, up 2. Find my next point, which was here, right 3, up 2. I'm at this point now, right 3, up 2. Now I'm doing this point, right 3, up 2. And then this final graph, right 3, up 2. And now I'm going to join them up. And now it's this shape, same size, just moved right 3 and up 2. And I'm going to label my final pink one that is the graph of negative 2 f at x minus 3 plus 2. So m's, that's all you need to worry about. And then you can go and do the worksheet that I've attached to the news post. It's a PDF. I forgot to give it to you in class. We're going to take a look at a couple more examples looking at K. So here I have another graph, and I'm going to call this one f at x, and I'm going to apply these individually. So the first one is f at 2x. So now this is multiplying my x inside. So that's k equal to 2. So k equal to 2 is actually a compression. It's going to compress the graph. And because it's opposite, I'm going to take all my x's and divide them by 2. So this x was at negative 4. So when I divide it by 2, it goes to negative 2. This affects the x, not the y. So the heights of the points stay the same. I'm just literally pushing them in. So this point was at negative 3. Negative 3 divided by 2 is negative 1.5. This point is at negative 2. Negative 2 divided by 2 is negative 1. This point is at negative 1. Negative 1 divided by 2 is negative 0.5. This point was at 0. 0 divided by 2 is still 0. Sorry, yep, that's 0. This point is at positive 1. Positive 1 divided by 2 is 0.5. This point was at 2. 2 divided by 2 is 1. And this point was at 3. 3 divided by 2 was 1.5. So hopefully you can see what I mean by it's as if you pushed it in this way. So that is f at 2x. So we took all of our x's, so all of our horizontal position, and we divided by 2, keeping the points at the same height. So they're just shifting horizontally to whatever that divided by 2 was. The next one, k equals 0.5. So there's a couple ways to do this. You can say, okay, I'm going to do x divided by 0.5 because in the brackets, it's 0.5. Another way to think about that is, 0.5 means literally divided by 2. That's how you find 0.5 of something. So you can multiply your x's by 2. So dividing by 0.5 or multiplying by 2 will give you the same answer. I'm going to go back to my original graph, and I'm going to take all the x's, and I'm going to either multiply them by 2 or divide by 0.5. And if you don't believe me, you can go into a calculator. But negative 4 times 2 is negative 8. Negative 4 divided by 0.5 is also negative 8. I find the multiplying by 2 easier, so I'm going to do it that way. But again, if you take all of your x's and divide them by 0.5, you'll get the same answer. This x is at negative 3. Negative 3 times 2 is negative 6. This x is at negative 2. Negative 2 times 2 is negative 4. Or again, negative 2 divided by 0.5. This x is at negative 1. Negative 1 times 2 is negative 2. This x is at 0. 0 divided by anything, divided by 0.5, or times by 2, it doesn't matter, it stays 0. This point was at 1, so it's going to go to 2. This point was at 2, so it's going to go to 4. This point was at 3, so it's going to go to 6. So this is a horizontal stretch. It's as if we grabbed the graph and pulled it out horizontally. Then the next thing we need to look at, well, what if k is negative? If k is negative, then it's going to be a horizontal flip. So instead of flipping it up and down like our A did, we're going to flip it left or right. So I'm going to take each of my x's and go to the opposite of it, keeping the point at the same height. So negative 4 is going to go to positive 4. This one is at negative 3, so it's going to go to positive 3. This is at negative 2, so it's going to go to positive 2. This is at negative 1, so it's going to go to positive 1. 0 will stay the same. This point was at positive 1, so it will go to negative 1. This point was at positive 2, so it will go to negative 2. And this point right here, because I'm only looking at the original black one, will go to positive 3. So this is the same size as our original black shape, but now it is flipped horizontally. So let's look at the worst case scenario. I have every number involved, including k. Now, this is also worst case scenario because what we're comparing it to is a, f at bracket, k bracket x minus p plus q. So a is the number in front, so I can see my a. Q is the number at the back, so I can see my q. Here's where it gets a little bit dicey though. K is not allowed to be right next to the x if there's a number at the end. This 2 is touching the x. I have to make it look like that. So I'm actually going to factor the 2 out. So all of this is after f, so I'm going to use square brackets to say I'm doing some work with this. I had 2x, I factor out the 2. I had negative 4, I factor out the 2. So the only one that it really changes is our p-value, but it always has to look like this. If your k value is inside the bracket touching your x, you have to factor it out if there's a number after it. If it was just 2x, it doesn't matter. It doesn't change anything. But if there is a p-value, a number adding or subtracting in the bracket, you have to take it into account as well. So now, a is 2, which is a vertical stretch. K is 2, which is a horizontal compression because it's the opposite. Then I'm going to go right 2, down 5. So you have to apply A and K first separately and then do right and down. So you always do A and K first. So A is a vertical stretch. A affects my height because anything vertical is the y. So I'm going to double all my heights. So again, same basic shape, but it's been stretched out a little bit. So I just took all my heights and doubled them. So this was a height of 3, so it went to 6. This was also a height of 3, it went to 6. 1 went to 2, height of 1 went to 2. This point had a height of 2, so it went to 4. I'm doubling it. This point had a height of 3, so it went to 6. Now I'm going to apply K, which is a horizontal compression. But because my final graph has all of these numbers together, it's not one at a time, I'm now going to work from the blue graph. So now K affects the horizontal, so I'm looking at the X. This X was at -4, so it's going to go to -2. So this point gets squished into -2. There was a point there originally that was at -2. It's going to get squished in to -1 because I'm doing all my X's divided by 2. This point was at 1, so it's going to slide over to 0.5. This point was at 1, so it's going to slide to 0.5. This point was at 3. That's the horizontal location, so when I divide it by 2, I get 1.5. This point was at 5, so when I divide it by 2, I get 2.5. So I still have that vertically stretched out shape, but now it's been horizontally compressed or squished in. Now the good news is you can do P and Q together at the end. So now I'm going to take each of my pink dots, because the pink represents first vertically stretched, then horizontally compressed, and now I'm going to go right 2, down 5. So 1, 2, 1, 2, 3, 4, 5. So I'm just starting at each pink dot, and I'm just counting right 2, down 5. Right 2, down 5. Right 2, down 5. Right 2, down 5. And finally, right 2, down 5. I lost my count. 1, 2, 3, 4, 5. So this is my final graph. This is 2f at 2x minus 4 minus 5. You could label it with that if you want to. I always went back to the original. And if we really wanted to get fancy, we can do domain and range of our graph. Remember, domain is x, range is y. For my x's, I'm going to look at my left and right walls. So I'm starting at 0, and I'm ending up at 4.5. My arrows always open the same way. And I'm actually starting at 0 and ending right at 4.5. Those are closed dots. So I put my lines underneath. Now for the y's, I look at my floor and my ceiling. The floor of the red graph is -3. The ceiling of the red graph is +1. My signs always open in the same way. And I can add in my or equal to or my lines underneath. So you're doing the same homework as the M's, that worksheet. But you have one other question to look at. It's on page 289 of your textbook, question number 15.